Okay, tomorrow there is a quiz. There will be 4 graphs you have to draw. One of them will have a removable discontinuity. One of them will have a slant asymptote. Should be pretty easy, unless it's not. But it should be. Oh, man. Good job. What do we have? What? 1B and D. 1B. Okay, so the first thing you gotta do is you gotta factor. Did you guys factor the numerator? Did you guys use synthetic division? Yes or no?
Yes.
Okay, so if you do synthetic division, what do you get? Somebody give it to me.
X minus 3, X plus 2, X minus 1.
That sounds right. And the bottom is x minus 2 times x plus 1. So there's no canceling, no removable discontinuity. So we'll go through the 4 things. X-intercept will be 3, negative 2, and 1. The y-intercept will be negative 3. Vertical asymptote, x equal 2, x equal negative 1. No horizontal asymptote, but since the degree of the top is bigger than the bottom by 1, there's going to be a slant asymptote, so we have to divide. So long division, did you guys do long division or do I have to do it? No, I love doing algebra 1. Algebra 1 to this day is still the most important course in mathematics, you know. X squared goes into there, x. So x cubed minus x squared minus 2x. Now, if you think about it, okay, you subtract, you can get negative x squared. You really don't need all the other stuff, but what the heck, let's just do it anyway. X squared goes into that how many times? Minus 1. That's all you really need, because that's the slant asymptote right there, right? You don't need to do the whole thing. So y equal x minus 1 is going to be the slant asymptote. And is it bothering you that that there's a point right on the slant asymptote? No, because they only take it back down here. So over here, since the graph got to pass through this point, it's got to be like this, yeah? And then look, odd powers on everything. That means the x-intercepts, they all go through, and on each vertical asymptote, they both go opposite ways. So exploding up, going to explode down. Okay, go through. Exploding up, you explode down, go through, and then follow the asymptote. I don't know, it's pretty standard, yeah? Then if it was so standard, why was it on the board? Answer me that. Anyway, tomorrow's quiz, I'm going to give you both the expanded form and the factored form, so there's no mistakes. Because some of you, if you factor wrong, that's a fatal error already. So it's kind of obvious. One of them is like I give you the factored form, get the 2 same factors. So if you don't cancel them out for the removable discontinuity, then just go home, cook rice. Right? Okay, now what do you do when you see absolute value? Skip to the next problem and write it on the board today. Come on, I thought I trained you. Piecewise function. When you go to calculus next year, it's got to be automatic already. Okay, so that's the absolute value. So it's going to be x is greater than or equal to 0 and x is less than 0, right? So when the inside is positive, you leave it alone. So you get x plus 1 over x minus 1. When the inside is negative, you negate it. But how do you simplify negative x plus 1 over x minus 1? Doesn't that just simplify to negative 1? Okay, so graph this one. X-intercept is negative 1. Y-intercept is negative 1. Vertical asymptote is x equal 1. Horizontal asymptote is y equal 1. So the graph looks like this. But we're only going to graph it when x is greater than or equal to 0. So we're only graphing it to the right of the y-axis. Like that. So basically everything else gets erased. So we're only keeping that part. And then when x is less than 0, then you just graph y equal negative 1, which is the horizontal line. So that's what the graph looks like. Yeah, Garrett's barbarians, that's going to be on the test. I'm going to have to put one problem with absolute value. You gotta know what to do with it. 2 BC equal. Okay, if you draw the graph, you should be able to answer all of these questions. Remember we talked about this yesterday? No, that's why it's on the board. X-intercept, -½ y-intercept, -1, vertical asymptote x equal 1, horizontal is y equal 2. So it's going to look like this. So in problems 2, B, and C, it's asking what's the limit as x approaches 1 from the right? No, B and C, from the left and the right. Look, here's x equal 1. Coming from the left, what's the limit going to be? What are the y coordinates doing? If they're shooting down there. The limit is -infinity. And what's the limit as x approaches 1 from the right? Well, if the graph is shooting upward, then the limit is infinity, then, right? Yeah, if you have the graph in front of you, right, limits are easy. Later on, we've got to figure out how do we figure out these limits without the graph. That's not that hard either. Wait a minute, how come you guys couldn't do 2 B and C, but you could do 3 B and C? Does anybody want to answer that question? Who wrote that on the board? 2 B, C.
Maybe the person didn't want to write 3 B and C because it's similar to 2.
I doubt it.
Yeah, I did it.
That was you.
Yeah. I didn't want to put 2 of the same column.
So this person didn't want to put 2 of the same column.
Yeah.
Whoever this person is. Okay, so who's not here tomorrow? Winto. So you
See you after school.
after school. Okay, it's got to be right after school.
Or period 8.
Okay, period 8 is fine. Okay, 5, 7, and 8. 5, right? Oh, we did this yesterday. Write irrational functions. In fact, it's almost the same thing. You guys, is this April 1? And it has a removable discontinuity at this point. Okay, so if you have a slant asymptote, what did I tell you yesterday? What has to happen? You have to do division and you get the quotient. So the slant asymptote, the quotient has to be the same as the slant asymptote plus the remainder over the divisor. Now what's the divisor going to be? Well, if you're going to have a vertical asymptote of x equal 2, what has to be in the denominator? X minus 2, so that's the divisor. And how do I figure out what this remainder is? Like we did yesterday. You plug in a point, there's the point. So if I plug in -1 for x and 1 for y, you get 1 equal -1 plus 1 plus r over -1 minus 2. These cancel out, so r equals -3. Is that correct? So y equal x plus 1 minus 3 over x minus 2. So that's your equation, except like I told you yesterday, we need to make at least common denominator. So x times x minus 2 plus 1. This looks eerily familiar. Doesn't this look almost exactly like yesterday's one? Should I replay the video? And if it's the same thing, you ground it. So y equals, okay, I'm going to skip a step. X squared minus 2x plus x minus 2 minus 3. Those numbers look almost exactly. X squared minus x minus 5 all over x minus 2. Box that, that's the answer. No, that was the answer we had yesterday. But see, this point is not just a regular point. It's a removable discontinuity. In other words, there's a puka there. Which means what? You have to cancel out factors, right, to get a removable discontinuity. So if you're going to have a removable discontinuity when x is -1, what factor has to be canceled out? X plus 1. So now, all you have to do is you just go x plus 1, and then multiply it up. So you just do the problem like normal, and then at the very end, then you make sure you put in the factor that cancels out. You know what I'm talking about? Garage Barons, this problem's on the test, which is on Tuesday. So today is the last lecture, and there's only one more worksheet. So like I told you yesterday, we're going to spend 5 nights to do 4 worksheets. So that's basically the homecoming mode work. Okay, 5, 7, and 8. 7. x is equal, okay, this is to see if you know what's going on. Okay, Garens, Barons, this is untested. Find the values of a, b, and c so that the limit of this function as x approaches infinity is 2. Now, when you see this, what do you think? Skip to the next problem and write it on the board. No! This means as the graph goes out to the right, the y-coordinates are getting closer and closer to 2, which means what? The horizontal asymptote is y equals 2. And how do you get a horizontal asymptote of y equal 2? The degree on the top and the bottom got to be the same, which they are, and the ratio of the coefficients has to be 2 to 1. So therefore, we can figure out that a is 2. A got to be 2. That's how you get horizontal asymptotes, right? And then the limit of this function as x approaches 2 from the left is negative infinity. What is that telling you? That means this means there's a vertical asymptote at x equal 2, right? Right? Because of x equal 2, if the limit coming from the left is negative infinity, that means the graph is shooting down like that. And how do you get a vertical asymptote at x equal 2? Don't you need x minus 2 in the denominator? Yes, so therefore c got to be negative 2, right? And then the last piece of information, that's the easiest. If you plug in 1 for x, you get negative 5, and that's how you figure out what b is. You guys can do that. So again, this is how we describe asymptotic behavior. And then number 8, f of x this is the exact same one we had last chapter. Find the values of a, b, and c so that f is an even function. Okay, I'm not going to go over this again, but if f is an even function, a got to be 0 already. Because if you plug in negative x for x, you got to get the same thing you started with, right? Because that's what an even function is. If you have to do the thing where you plug it in, and remember how we compared, one of these things is not like the other. If you have to do that, do that. But hopefully by now, you just know a is 0 already. Okay, and then it says, the limit of this function as x approaches 2 from the right is negative infinity. What does this mean? There's a vertical asymptote at x equal 2. Because look, here's 2. If the limit as x approaches 2 from the right is negative infinity, that means it's going down like that. That means you have to have a vertical asymptote at x equal 2. Which means you need x minus 2 in the denominator. Yeah, but Mr. Park, it's x squared. Yeah, that's because this is an even function. What is the property of an even function? It's symmetric about the y-axis. So if you have a vertical asymptote there has to be a vertical asymptote at x equal negative 2 because it has to be symmetric about the y-axis. So that means you need x plus, not only x minus 2 in the denominator, but you need x plus 2 in the denominator. But doesn't that multiply out to x squared minus 4? And that's how you have an x squared here. So that's why we figure out that c is negative 4. And then the last piece of information is just plug in, yeah? You guys get it? Even, that's why. Even means symmetric about the y-axis. And then number 9, very good. Okay, this problem is definitely on the test, except be kicked up a notch. As you will find out. Okay, today's lecture is on partial fractions. So this is the last thing we're going to cover. Now, how many, look at the notes I gave you on partial fractions. How many of you remember this from last year? I think Mr. Rubash said he made it a bonus quiz or something. Who had Mr. Rubash? A bonus quiz? Mr. Park, whenever he says bonus, I just don't do it. Okay. And what about Mr. Tagi's students? Did you guys cover this? Partial fractions? It doesn't matter. I'm going to teach you like you don't know anything. Okay, first of all, let's go back to Algebra 1. What if I ask you to do this? What is 2 over x plus 1 plus 3 over x plus 2? How do you add fractions together? How do you add fractions together? You make it rhymes with least common denominator. You make a least common denominator. And then what? What goes on the top? 2 times x plus 2 plus 3 times x plus 1. And then you simplify out the top. Okay, I'm just going to do this. So that's 2x plus 4 and 3x plus 3. So there's going to be 5x plus 7. Did I do that correctly? Skipping a step there. Okay, easy, right? Okay, now we go backwards. What if I give you this, and I ask you to decompose it into its partial fractions? That's not so easy. That's why you have to wait till Algebra 2 to learn. In this case, pre-calculus. Okay, so if you're given this, how do you decompose it into its partial fractions? Okay, well, I'm going to teach you how. It's a very simple technique. Well, one way is guess and check, and that might work on the easy problems, but when you get to the more complicated ones, you're not going to guess and check. So we want to have a technique where we can rely on. Now, this is super important in calculus. Next year. So you guys need to remember this. Okay, so when we start, well, first thing, this method I'm going to teach you only works on proper fractions. Like, what's a proper fraction? Okay, let's go back to elementary school. Is this a proper fraction? Yes. Is this a proper fraction? No, we call that an improper fraction, right? Why? Because the numerator is greater than or equal to the denominator. Okay? So when you have variables, it's the same thing. A proper fraction is when the degree of the top is smaller than the bottom. Is it? What's the degree of the top? Rhymes with bun. What's the degree of the bottom? Rhymes with move. 2. Is 1 smaller than 2? Wait. Yes! So this is a proper fraction. So yes, you can start the method. Because sometimes, if you look at tonight's homework, some of them are not proper fractions. So if they're not proper fractions, what you have to do is you have to divide first. Which it says in the notes. Okay, now we've got to use common sense, which might be the hardest part for you guys. What fractions do I have to add together so that this will be the least common denominator? Yeah, okay. Something over x plus 1 plus something over x plus 2. Everybody agree? Yeah, because, okay, I'm showing you an easy example, but then it's going to get tougher. That's the common sense right there. What fractions do I have to add together so that this will be the least common denominator? So all you have to do now is figure out what a and b are. Well, if you look over here, well, obvious a got to be 2 and b got to be 3, but you can guess and check that, but like I said, on the harder problems, you're not going to be able to do that. So we want a method where we can figure it out. So watch what I'm going to do. First step, I'm going to multiply both sides by the least common denominator. And every year, for some reason, some students screw this part up. Okay, don't do that, because that would be a fatal error. Multiply both sides by the least common denominator to get rid of all the fractions. Okay, now, once you get to this step, there's 2 things you can do. One thing is called equating the coefficients. What's that? Well, again, that's using common sense. Okay, and they have lots of these on the SAT now. Okay, what if I said this? Cx squared plus dx plus e is equal to 2x squared plus 3x plus 5. If you have an equation like this, what conclusion can you draw? C must be equal to, D must be equal to, and E must be equal to. That's called equating the coefficients. See, the coefficient of x squared got to equal to the coefficient of x squared there. The coefficient of x got to equal to the coefficient of x there, and the constant here got to equal to the constant there. That's called equating the coefficients. So we're going to do exactly the same thing, except we've got to do some work. So 5x plus 7 equals, you got to multiply this up. ax plus 2a plus bx plus b. Now, gather the like terms. So there's 2x terms. What's the coefficient? A plus b. There's 2 constant terms, right here and here. You write that here. Okay, so using the equating coefficients concept, therefore, a plus b has to equal to 5. The coefficient of x on the right got to equal to the coefficient of x on the left. And the constant on the right got to equal to the constant on the left, which is constant got to equal 7. And then you have two equations, two variables, you just solve it. It's algebra 1. So line them up. This is what I would do if I were me. Line them up, add or subtract. Subtract, because the b's cancel out, so you get a equal 2. And once you figure out a equal 2, plug it into here, and then you can figure out b is 3. So therefore, to decompose this into partial fractions, this would equal 2, and this would equal 3, which is what the original problem was anyway, right? This is the part that's a lot of work. Yeah, and that's an easy problem. It's not easy to go backwards, you know, but you have to do this in calculus next year. So that's one method. It's called equating the coefficients. So Mr. Park, is there another method? Bet you bit me there is. Okay, so once you get to this step, I'm going to rewrite that step right there. Once you get to this step where you get rid of the denominators, okay, instead of equating the coefficients, because it takes a lot of work, just imagine how much work there would be if you had like, what if you had like 5 factors? Woo! You don't want to use equating the coefficients in that case. Maybe there's something else we can do. Yeah, so back in the, I think it was in the 1700s, Oliver Heaviside said that, woo, instead of equating the coefficients, why don't I just plug in numbers for x? So he said, woo, I'm going to plug in -1 for x. Why do you think he's going to plug in -1? Because it makes that thing 0. So if you plug in -1 for x, what do you get? Just do it. Wherever you see x, plug in -1. Go. 2 equals. People, if you cannot plug in whole numbers, a plus 0. Oh, we just figured out a is 2. Oh, see, Oliver Heaviside is pretty smart. And then he goes, oh, to figure out b now, I'm going to plug in another number. What number do you think he's going to plug in? -2, because that makes that thing 0. So if you plug in -2 for x, you get -10 plus 7 is -3 equals 0 plus -b. So therefore, b equals 3. This is called the Heaviside method. Now, which way do you like better? Duh! Right? The Heaviside method is much faster. But that's because we only have linear factors. When we get to quadratic factors, then the Heaviside method is not going to be the fastest all the time. So when you do your homework, you got to figure out which method is going to be the best. Is it equating the coefficients, or is it Heaviside, or is it like a hybrid? That's what you got to figure out on your homework. Okay, so that's how. So, like I said, we have two techniques: equate the coefficients or Heaviside method. Okay, so the key step is setting up the problem, because if you don't set up the problem correctly, it's all over but the crying. Okay, so let's practice setting up the problem, okay? So let me make up something. How about 2x squared plus 3x plus 5 all over x plus 1 times x plus 2 times x plus 3. Is this a proper fraction? Yes, because look, the degree of the top is 2, but the degree of the bottom is 3. So if you have a proper fraction, you can just go ahead. Now this one is easy. What fractions do I have to add together so that this will be the least common denominator? Something over x plus 1 plus something over x plus 2 plus something over x plus 3, right? And that's how you would set up the problem, and then you go from there, and the Heaviside method would be the best thing to do here. Everybody get that? So when you just have linear factors that are not repeated, easy. Okay, but now let's kick it up a notch. I'm not going to finish the problem. I'm just setting it up because you have to understand how to set up the problem. What happens when you have repeated linear factors? Like for example, what would happen if you have x plus 1 cubed, x plus 2 squared? Like this. See, it's a linear factor, but since it's raised to a power, we call that a repeated linear factor. So what fractions do you have to add together so that this will be the least common denominator? Now, this is what a lot of people say. They go, oh, something over x plus 1 cubed plus something over x plus 2 squared. Wrong. Fatal error. Yeah, but Mr. Park, if I add these two fractions together, that's the least common denominator. Yes, I agree, but you're not accounting for all the cases. So that would be a fatal error. So watch what I do. It's something over x plus 1 plus something over x plus 1 squared plus something over x plus 1 cubed plus something over x plus 2 plus something over x plus 2 squared. That's how you set up the problem. I don't get it, Mr. Park. Well, let me ask you this. If I were to add these 5 fractions together, what would be the least common denominator? That? No further questions, Your Honor. So, if you want a recipe, anytime you have a linear factor to a power, you have to have that plus everything that comes before it, all the way down to the first power. So if this was 6 power, you would have to have first, second, third, fourth, fifth, and sixth power. Anyway, I'll give you examples in the notes right, so you can follow. Everybody understand that? Okay, now what happens when you have quadratic factor? I'm just going to use the same numerator. What if you have like x plus 2 times x squared plus 1? Now this is a linear factor, right? First power. But this is a quadratic factor. See how you can't factor this anymore? See, because if you could factor it, then you just get linears, but you can't factor that, so it's a quadratic factor. Is this a proper fraction? Yes, the degree at the top is smaller than the bottom, so we can go ahead. So what do? What fractions do I have to add together so that this will be the least common denominator? Use common sense. Something over x plus 2 plus something over x squared plus 1. Correct? Wrong, fatal error. Yo, Mr. Park, it's right. No, it's not. Here, I'll make it right. This should be bx plus c. What? Why? Well, how come when you have, why is it that when you have a quadratic factor, then the numerator has to be like bx plus c? How come I just can't put b? Because what is a proper fraction? The degree of the top is smaller than the bottom. So what's the degree of this? Rhymes with bun. 1. What's smaller than 1? 0. A constant, right? But the degree of this is 2. What's smaller than degree 2? 1. So that's why you have to have x to the first power. It's got to be 1 degree less. Okay, now what happens when you have repeated linear and quadratic factors? So like what if you have x plus 2 cubed and x squared plus 1 squared? What if there's powers on them? What do? Well, this is what you do. So it's going to be something over x plus 2 plus something over x plus 2 squared plus something over x plus 2 cubed. Right? We already learned that, right? But then what do we do for this one? It's going to be dx plus e to the x squared plus under x plus, and then fx plus g all over x squared plus 1 squared. You guys get it now? Like I told you, when you have a repeated factor, you got to have that power plus all the ones that come before it. So same thing with this. If it's squared, you got to have that, but then all the ones that come before it too. And every time you got to put the ax plus b on the top. Okay, so using the same reasoning, now I would never give you a problem like this. I'm just showing you this so that you understand, okay? Probably the most number of letters you're ever going to find is 4. You're not going to find more than 4 letters. Unless this year we're going to find more. What happens when you have something like this? What if you had x squared plus 1 and then x cubed plus 2? How would you set up this problem? Now see, this is a cubic that's not factorable. How would you set that up? What fractions do I have to add together so that this will be the least common denominator? Something over x squared plus 1 plus something over x cubed plus 2. Right? Okay, but what's the something on the top? What do I put on top here? Ax plus b. What would you put up here? cx squared plus dx plus e. Because this is degree 3. What's smaller than degree 3? 2. No, I'm not going to give you that, but I'm just showing it to you so you understand what's happening here. You guys get it? Okay, so why don't I do one of your problems for homework then, so you get less homework. Let me look. What do you got? You gotta be choking.
0.
No, and do not solve. Come on. Okay, I will do. Okay, here. You're gonna make me do this anyway. What time is it? Oh man! Thought we were gonna play games today. Apparently not. Okay, pick one. Pick either 3, 4, 5. 3, 4, or 5. Pick one of those. Those are medium problems. Just because it's the biggest number. That's dumb. So what if I said 4, 5, or 6? You can pick 6.
Yeah.
That's stupid. Okay, let's do 5. I'm gonna do 5. Let's do 5. 5x squared minus 2x. 5x squared minus 2x minus 1 all over x minus 2 times x minus 2 times x squared plus x minus 1. Is this a proper fraction? And I hope you guys notice, look at problem 7 and 8. 7 and 8 are not proper fractions. So what you have to do is you have to divide before you start. Okay, here we go. What fractions added together will give you this as the LCD? Well, something over x minus 10. Something over x minus 2 plus something over x squared plus x minus 1. What do I put up here? What goes here? A. What goes up here? Second power. Bx plus c. You don't have to use ABCs. You can use other letters if you want. Okay, now multiply both sides by the least common denominator. So you get 5x squared minus 2x minus 1 is equal to a times x squared plus x minus 1 plus bx plus c times x minus 2. Okay, so now you have to decide. Do I want to use the Heaviside method? Do I want to equate coefficients? Or do I want to use a combination of the two? I don't understand. Well, okay, I'll tell you what. To equate coefficients, you have to multiply out everything. Okay, here. Let's just do this for fun. So bx squared minus 2b plus cx minus 2c. Did I do that correctly? Of course, I'm the teacher. Okay, so now, you got 2x squared terms. What's the coefficient going to be? A plus b. You have 2x terms. What's the coefficient? Look at the 2x terms. What's the coefficient? A plus c. And then you have constant here. What is that? Negative a minus 2b minus 2c. So if you equate the coefficients, a plus b got to equal 5, right? A plus c got to equal negative 2. And negative a minus 2b minus 2c got to equal negative 1. Yo, Mr. Park, I don't want to solve 3 equations, 3 variables. Okay, don't then. That's why you can use a combination of the two. Heaviside method. Okay, what's a good number to plug in for x in this equation here? 2, because it makes this thing 0 here. So if I plug in 2, go. If x is equal to 2, plug in 2. 20 minus 4 minus 1, which is 15. That equals, plug in 2 here. 4 plus 2 minus 1. 5a plus 0. Oh, a equal 3. Oh, and then once you figure that out, oh, once a is 3, b is, and c is, oh my gosh, if a is 3, b is 2, if a is 3, what is c? Rhymes at negative 5. You got to be joking me. See, that's a combination of the two right there. Yeah. C is negative 1.
There's the 2b in the quadratic. There's an x in the original.
Oh, this is 2b. What? Oh, this is an x. Oh, so we did it all wrong.
Oh, and b is correct.
Silence. We did it all wrong. How come only now, after we almost finished the problem, you speak up? So we got 3x terms, a minus 2b plus cx, and then only got two constants, negative a minus 2c. So start all over just for that. A plus b got to equal 5. A minus 2b plus c equal negative 2. And negative a minus 2c is equal to what? Negative 1. And then using the Heaviside method, what did we figure out? A equals 3. So if a equals 3, plug that in here, b equals 2. But if a, just go right here. So if a is equal to 3, what do we got? C is negative 1. See, and then that way you don't have to solve 3 equations, 3 variables. You know what I'm talking about? But it's up to you. You can do all equating coefficients, or you can just use Heaviside method all the time. You don't even have, you guys know what I mean. You guys don't know what I mean. Okay, Mr. Park, okay, what if you just said, okay, Mr. Park, I don't like the equating coefficients method because you gotta multiply out everything, especially this is an easy one. Wait till you see the ones you'll get later. I don't like the equating coefficients, then don't do that, just do Heaviside the whole time. What's a good number to plug in for x? Well, we already said so, what is it, 2. 15 is equal to 3a, no, 5a full, therefore a equals 3, right? Okay, see, but the thing is, if you're gonna find 3 letters, you gotta plug in 3 numbers. So what's another good number to plug in for x? See, the beauty of the Heaviside method is you can plug in any number you want. You don't have to plug in 2, but it just makes it easier if you do, right? So what would be the next number you plug in for x? See, but we've run out of good numbers because there's no number I can plug in for x here that'll make it come out to 0 because it's imaginary, right? This one has imaginary roots, so you can't do it. So, but you still got to plug in a number. What would be a nice number to plug in? 0 or 273? Or negative 5,742? I think 0 would be better. Oh boy. So negative 1 equals negative a. But we already know a is 3, so negative 3. If I plug in 0 there, you get negative 2c. Oh, so therefore c equals negative 1. You can plug in any number you want, people. Okay, now, to figure out b, we've got to plug in another number. What do you think? What's a nice small number that's not 0 or 2? 1! Why you want to plug in 3 when you can plug in 1? No, let's plug in, okay, what about 17 then? 1. 5 minus 2 minus 1. 5 minus 2 minus 1. 2 equals, plug in 1 here. 1 plus 1 minus 1 is 1a, but we already know a is 3. Plus b plus c, but we already know c is negative 1. And then 1 minus 2 is negative 1. Do you think I can solve for b in that equation? Well, I can. I don't know about you. So negative 1 is equal to b minus 1 times negative 1. So therefore, b minus 1 equals 1. So b got to equal 2. Whew. See, so I did just Heaviside the whole way. That's why there's so many different ways, and I don't care how you do it. I'm just looking for the result. And to help you out, I'm always going to make a, b, and c come out to whole numbers. No, integers. Because something negative as well. Negative. So if you're doing the problem on next week's test, and it comes out you get b is 43 over 17. That's not correct, because that's not an integer. You guys know what I'm saying? In fact, I'm going to narrow it down integers between negative 10 and 10. So it's going to be single-digit integers. I tell the class that every single year, but you know what? They still get, their answer is, oh, b comes out to negative 43 over 217, and they just leave it and they keep going. Come on, you see that? You did something wrong. Okay, we're done. Oh my gosh. 1 minute left. No videos today. Anyway, there's no more lectures, so tomorrow we just go over the homework and then we just play games or whatever. Watch videos.